Hi everyone, Miss Gaynor back here. I hope you're excited because today is the day that we get to actually get really into stoichiometry. I'm excited. The skeleton over here is super excited. He's grinning really widely, so you should be excited too. So, to review from what we did yesterday, not Tuesday, but yesterday we talked about mole to mole conversions. So we talked about, if we want, first off, we have a balanced equation. This means that for every 4 moles of sodium, there's going to be 1 mole of oxygen and 2 moles of sodium. So take a minute, pause this video, and figure out how many moles of sodium do you need to react with 5.43 moles of oxygen. So again, pause this video here, solve this problem, and check back when you have solved it. And now that you're finished, we can see that we have 5.43 moles of oxygen. That means that for every 1 mole of oxygen, there's going to be 4 moles of sodium. So multiply everything on top, divide by everything on the bottom. 5.43 times 4 gives us 21.7 moles of sodium. Nice work, and let's keep going. Now what we want to do is, when we talked about yesterday, we want to figure out what mass of ammonia is going to be produced if we have 8.90 moles of nitrogen. So this is a little different because we're going to go from moles to mass. So first off, let's set up our equation. Nitrogen is N2, hydrogen is H2, and ammonia has the formula of NH3. So next step is to balance this equation. So this means that for every 1 nitrogen, we have 3 moles of hydrogen and 2 moles of ammonia. Now make sure you copy this down. Whenever we were going from mass to mass stoichiometry, we want to go from the given mass to given moles, to wanted moles to wanted mass. We'll see how this works off. But we're going to start off with our given moles. The moles that we are given is we are given 8.90 moles of nitrogen. And we want to find the mass of ammonia. So this is our given moles is 8.90 moles. And we want to find the mass of ammonia, so that's the wanted mass. Now to convert this, we're going to start off with that should be 8.90 moles of nitrogen. Convert it to, for every 1, convert it to the moles of ammonia. So what we're doing is we're going from given moles to wanted moles. So we're going from moles of nitrogen to moles of ammonia. So for every 1 mole of nitrogen, there's going to be 2 moles of ammonia. So that's the first step, going from given moles to wanted moles. The next step is to go from wanted moles to wanted mass. So here we're converting from moles of ammonia to the mass of ammonia. So we set it up on the bottom. We're going from moles of ammonia to mass of ammonia. For every 1 mole of ammonia, it's going to weigh 17.04 grams. 17.04 is the molar mass of ammonia. So 1 mole is going to weigh 17.04 grams. Now we've got all of our railroad tracks set up. The next step is just multiply everything on top, divide by everything on the bottom. So that's 8.8 times 2, 8.9 times 2 times 17 gives us 303 grams of ammonia. So that's our final answer, that's our wanted mass. Now let's look at another example. Here we have 24.9 grams of zinc oxide. And we want to know how many grams of carbon dioxide gas are going to be produced. So the first step is to balance this equation. So we've got 1 mole of carbon, 2 moles of zinc oxide, 2 moles of zinc, and 1 mole of carbon dioxide. Again, we want to find the given mass. So our given mass is 24.9 grams of zinc oxide. We want to go to find the wanted mass. Our wanted mass is going to be grams of carbon dioxide gas. So we need to know from given mass to given moles to wanted moles to wanted mass. So what that means is we're going to start off with our given mass. We start off with 24.9 grams of zinc oxide. The next step is to go from mass to moles. So to go from mass to moles, we want to figure out how many grams of zinc oxide are in 1 mole. Using the molar masses on our periodic table, we know that 1 mole of zinc oxide is equal to 81.39 grams. So now we've gone from given mass to given moles. We have our given moles now. Next step is to go from given moles to wanted moles. That's converting from moles of zinc oxide into moles of carbon dioxide. Notice how zinc oxide on top, moles of zinc oxide on the bottom. Grams of zinc oxide on top, grams of zinc oxide on the bottom. Now using this reaction, we know that for every 1 mole of carbon dioxide, we're going to have 2 moles of zinc oxide. So now we've gone from given moles to wanted moles. We now have moles of carbon dioxide. And our last step is to convert from moles of CO2 into grams of CO2. So we set it up that 1 mole of CO2 is equal to 44.01 grams. That's the molar mass of carbon dioxide. Now to solve this problem, we're going to multiply everything on top, divide by everything on the bottom. So that means it's going to be 24.9 times 44.01. Divide that answer by 81.39, divide by 2, and we end up with 6.73 grams of carbon dioxide. So that's our final answer. Now looking at example 3, what you should be doing for this problem is pausing and then moving ahead with the video to check your work. So, whenever I've set up the problem, pause, work this problem through on your own, and then you can play the video to check your work. So here we know that there's a combustion reaction. So silver in a combustion reaction forms silver oxide. So the first step is to write out this reaction. So that means when it's combusting means it's reacting with oxygen. So silver is going to react with oxygen and form silver oxide. Next step is to balance this equation. We end up with 4 silvers, 1 oxygen, and 2 silver oxides. We've got our equation for solving stoichiometric problems. And we're going to start off with our given mass is 5.2 grams of silver. So that's our given mass. And our wanted mass is going to be the mass of silver oxide. That's our wanted mass. So, pause this video, solve through this problem, then play to check your work. So we start off with 5.2 grams of silver. We want to convert from mass to moles. So, for every 1 mole of silver, that's going to weigh 107.9 grams. So that's going from mass to moles. Notice grams of silver on top, grams of silver on the bottom. Now to go from given moles to wanted moles, we want to set up as moles of silver to moles of silver oxide. Silver on top, silver on the bottom. So for every 2 moles of silver oxide, we're going to need 4 moles of silver. To go from wanted moles to wanted mass, we've got moles of silver oxide on the top, so we're going to put moles of silver oxide on the bottom. And converting to grams of silver oxide. 1 mole of silver oxide weighs 231.8 grams. Multiply everything on top, divide by everything on the bottom, and we end up with 5.6 grams of silver oxide. So for the last problem, go through this problem if you want some more practice. Otherwise, if you feel confident, then go ahead and start on your tiered stoichiometry problems. However, if you want some more practice, want to see another problem, keep watching the video. You'll be glued to your seats with entertainment. So to start off with, we've got the reaction of phosphorus reacts with bromine to form phosphorus tribromide. Set up our balanced equation. We know that means phosphorus reacts with bromide, it's one of our Brinkelhoff elements, to produce phosphorus tribromide. Balance this reaction. We've got a ratio of 2, 3, and 2. Now we know that our given mass is going to be 78.2 grams of phosphorus. That's our given mass. And our wanted mass, for this one, it's not a wanted mass, we're actually going to want in moles. Now keep in mind what the question's asking you for. And this question is asking you for how many moles of bromine are produced. So this means we're going from given mass, that's 78.2 grams, to wanted moles of bromine. We start off with 78.2 grams of phosphorus. 1 mole of phosphorus, going from mass to moles, 1 mole of phosphorus is 30.97 grams. Now we want to go from moles of phosphorus, from given moles, to wanted moles. So we want to convert from moles of phosphorus to moles of bromine. Now looking at our equation, for every 2 moles of phosphorus, that's equal to 3 moles of bromine. And because we have what we want, we have moles of bromine, we can stop right here. We don't have to convert it to grams. So once again, multiply everything on top, divide by everything on the bottom. And we end up with 78.2 times 1 times 3, divided by 30.97, divided by 2, which gives us 3.78 moles of bromine. Now that you've finished the video, like me on YouTube, help me to start them, and start working on your tiered problems. So,